Hey there, listen to this. And now watch it roll in. Now back to the beginning, the hardware. The central piece is an ESP32 board. My setup is pretty simple and handmade. What you can see here is the board itself, the motor, the battery, and the receiver, and there's the loudspeaker. I got most of the parts from Amazon. The ESP32 dev board is now down to about €6. I also bought the voltage converter, a dual H bridge, and the stereo audio amplifier. The rest is just a couple of resistors and some transistors to drive the LEDs. If you want to build one yourself, I would propose that you place the audio amplifier at a distance to the 2.4 GHz antenna. For a more professional setup, you can have a look at the Arduino RC Engine sound and light controller for ESP32 project. I will link that in the description. So now let's talk about functionality. Just imagine that you have all these signals coming in from the receiver. Then the software does something with the signals, modifies them, processes them, and eventually outputs them. And that's what's happening now inside the software every 20 milliseconds. We read the signals in, then do some magic, and eventually put them out on the processor pins. These signals, the ones that I'm using internally, they are 16-bit signed values. The normal range is -1000 to 1000, where 0 is the neutral point. And there's also a special value for an invalid signal, one that was never set. The signals, however, are not actually limited to the 1000 range. They can be larger to represent other stuff than an RC input signal. But the logic in principle is always the same. And you can also see the signals in the front end. I haven't mentioned that before. Yes, there is a front end. It's using the Bluetooth API and it allows you to view all the internal values and even manipulate them. It's really neat. And this is how it looks like. You have this list of all the signals and you can see the internal states. But first you have to connect to the controller, which might take a while. But once this is done, I can set the internal state by just clicking on the slider. They will turn orange and that means that they are now preset. Now the ESP does its thing, processes the signals, outputs them via hardware, eventually sends them back to the front end. And these are the blue sliders, these are the blue values that you see here. Throughout the software they might be changed. In some cases you have the orange bar and also a blue dot. The orange is the initial value that I'm setting via the front end and the blue one is the one after the whole processing has happened. Regarding the signals, we have a big list of signals, but don't start looking for your favorite signal now. We don't have this big list because they are all different, because they are not. We have this list because there's a lot of stuff we want to do within one model, and it's easier to handle if they are clearly labeled. The second term that you have to learn about is procs. Procs are procedures, configuration parts within the software. They can be chained together however you like, and will take signals and do something with it. Most of them are pretty simple and straightforward. Take the cranking proc, for example. It will dim down some signals if cranking is detected. The results are just written back, and the next proc can continue with its thing. There is an overview to give you an idea about the available procs. Some of these procs, they take input from the hardware and generate a signal. Then we have a lot of procs which do things to the signals or on the signals, like the map, for example, which allows you to map a signal so you can invert them, map to different ranges and so forth. Then we have a couple of output procs. They will take a signal and put it out via hardware. Each output has its own proc. There is one for servo control, one for lights, a motor controller, and one for audio output. The audio procs will generate audio for the audio output proc. They range from the basic simple audio proc on one end to the engine audio proc, which will blend up to 5 samples depending on various conditions. Now all these procs and settings and all this stuff is not fixed at compile time, so you can change them again via the front end via Bluetooth. It's fairly simple. Let's say we want to make our model to sound like a duck. We leave the input and the output groups alone and just remove this vehicle group there. So the first thing is a quacking sound. So we add a simple audio proc, and the sound should be triggered on the horn signal. As a sound, we select custom and then load a sample. It doesn't have to be a WAV file, by the way. It can be anything that the browser understands. So for example, MP3 is good. The next thing is we want the sound of feet, of little duck feet. So we make another simple audio proc and we set as the trigger the signal speed. We will change that in a minute, by the way. As for the sound sample, again, select custom and then a sound file. Now, since this is supposed to be the sound of little duck feet, we don't want this sample to play only once. So we need a periodic proc. As an input signal, we set speed, and as an output, we set aux1. And now we can also fix the input signal of the feed sound procs to its final aux1. Depending on your input setting, you might not get a speed signal, but instead a throttle. So we use the export proc to create a speed signal from throttle. And finally, a smooth acceleration would be nice. So we add a fade proc to smooth the speed signal. And now we also need to correct the sequence. The procs are executed in order, so fading a non-existing speed signal and then copying from a throttle signal won't work. That's it. Let's put everything into a nice group. Again, the order needs to be correct. First the input procs, then the processing and output at the end. upload the whole thing. And there is our duck. So that's it for now as a brief introduction. I hope you feel motivated to try it out yourself.